Hello YouTube, this is Umozo3. So this is lesson 30 in our conversation on Java programming fundamentals. And for this lesson, we're going to be talking about something called recursion. So recursion is a technique that doesn't always come intuitively to people. It's a little bit confusing, a little bit weird how it works. But basically, it's going to be a technique that allows us to print repeated code. And basically, it's an alternative to writing code iteratively. So we've talked about while loops and for loops, and we know that those are basically two main solid techniques for iterating through code and printing multiple lines. But what we could do is we could figure out a different way to basically achieve the same task. And that's that instead of iterating through code, and since instead of just repeating the same procedure multiple times, what we can do is we can take the same problem over and over and over again and reduce it to the same problem of a smaller size. And what that would allow us to do is basically solve a problem that is large and complex, but break it down into simpler and simpler cases until we arrive at something that we do know how to solve. And then from there, we can work up to whatever we need to work up to. So I don't know how much math you guys have studied before, but there are a couple of mathematical sequences and functions that are recursively defined. And so we're going to talk about those. So the first one I want to talk about is the factorial. So we know mathematically the concept of a factorial, and essentially the way that it works is if you have 5 factorial, you would do 5 times 4 times 3 times 2 times 1. But it turns out that the way that the factorial is defined is actually a little bit more formal than that. So what we're going to do is we're actually going to come up with 2 implementations of the factorial method. First, we're going to write an iterative factorial method that simply uses a while loop. And then we're going to figure out how to define factorial recursively. And so that'll be our first example. And so we're going to see different examples of recursive functions, and hopefully you'll get a good understanding of intuitively what recursion is and how you can come up with your own recursive methods. So what we're going to do is we're going to say public static int, we could say iterative factorial. Let's call the method iterative factorial. And we're going to practice making Javadocs because in the previous video we talked about documentation. And so we're going to want to have good documentation for this method. And so what we're going to do is we're going to do the Javadocs. So remember, you're going to do a / and then you're going to do 2 stars. And we want to get into the habit of having good documentation for any methods that we write in the classes that we're responsible for writing. So what we would do is this method is say this method returns the nth factorial number. Okay, so for example, iterative factorial of 3 should return 6 because 3 times 2 times 1 is 6. And so that just gives an example of, to just so that people understand what's going on. And so what you would do is now you have to specify any parameters and any return values. So you would say param n, I guess that number factorial. So I guess the index position in the factorial sequence that we would like starting at index position 1. So the first number it would be n equals 1, so corresponding to n equals 1. Just for it's up to you how you'd want to define it, but we're going to say that if we put in n equals 1, we're getting the first factorial, so we would get 1 factorial. Okay, so what you would do is you would say something like return n factorial, and so here's what we're going to do. So, or you could say with a comment, the factorial of n or something like that. And then what you would do is, so let's think about this, because what you would have to do is you would say int result equals 1. And then what you would do is you could say something like for int g equals n, g is greater than or equal to 1, g minus minus. And then what you would be doing is you would just be multiplying your current result by the current value of g. So if you were looking at 4, you would do a result is equal to the result times 4, and then you would do result is equal to the result times 3, result is equal to result times 2, and then result is equal to result times 1, and then that would have the effect of multiplying your 1 times 4 times 3 times 2 times 1, and then you would get that 24 that you're looking for. And so then you would just go ahead and return the result. And so that would give you the result. As long as it was at least 1, it could be any positive number, and hopefully that code would give you what you're looking for. And so we can go ahead and test it. We don't even have to run the main method. We can just go ahead and test it right here. And so we can run this int, and you can see the documentation that we wrote. So I was saying at the end of the last video that if we write documentation and then we just do a call to one of our static methods, then this documentation will appear. And so people will know exactly how it works. So we know that 5 factorial should be 120, and that's exactly what we get. But there's another way to write this factorial method, and that's to do it basically by calling on the factorial method itself. And so a recursive method, you could write a comment, a recursive method is a method that calls on itself. And so that's the point that I'm trying to drive home here. So what we're going to do is we're going to come up with another method, and it's going to also compute a factorial, but it's going to do it in a different way. So we're going to say recursive factorial of n. Okay, and then you would have documentation for this method too, because it is a separate method. So it might be pretty similar, right? We could do probably some copying and pasting, but returns the nth factorial number. And you could say, you could add a comment. So this is a recursive implementation, which will call on the method itself with lower and lower values of n. Because what's going to happen is we're going to define n factorial as being n times n minus 1 factorial. That's the definition of it, is the factorial is actually defined by another factorial. And the only way that you're going to boil down, the only way you're going to arrive at like a bottom or a base case is to mandate that the factorial of 1 is 1. So here's what I mean by that. So you would say if n equals 1, if n is equal to 1, what you would do is you would say return 1. But otherwise, if n is bigger than 1, what you would be looking at is you would say return n times recursive factorial of n minus 1. And the reason why that works, this is literally the definition of the factorial. So you know in math, n factorial equals n times the factorial of n minus 1. And what's the factorial of n minus 1? Well, it's n minus 1 times the factorial of n minus 2. Well, what's the factorial of n minus 2? It's n minus 2 times the factorial of n minus 3. And you can see how eventually you're going to boil down to this case. And so if you started at, recursive factorial of 3 and we were looking for that 6, it would be 3 times recursive factorial of 2. Well, what's recursive factorial of 2? It's 2 times recursive factorial of 1. Well, now we know what recursive factorial of 1 is. So it would be 3 times 2 times 1. It has the exact same effect as this for loop, but we literally just write one if-else statement. And how is that possible? Because the method is being called multiple times. It's being called over and over again. And every single time we're multiplying by the new value of n until we drive all the way back down to 1, in which case we would just be multiplying by 1 at that step. So now we can go ahead and test this method with the recursive factorial. I mean, you could have another test, you could have a tester method to make sure that the methods return the same thing. So what you could do is you would say, you would say equal values, and you could test both of the methods for different values of n. And so you don't even have to have any inputs coming in here, but you would just want to go ahead and say Boolean same equals true, assume that you're going to get the same result, but you could run it for 10 different factorial values. And then if at any point one of those factorials gives 2 different results between the iterative and the recursive version, then you could switch this variable to false. So hopefully we're expecting true, but you would do basically for int v equals 1, v is, you could go up to like 10, and then you could say v plus plus, and then if at any point, if those 2 methods returned different results, then you would flip same to be false. So you could say if iterative factorial of v is not equal to recursive factorial of v. So we're getting into a lot of detail right here, but I just want to show you that these are 2 different ways of doing the same thing. You could either do it with a for loop, or what you're going to do is you're literally going to call the method on itself, but with smaller and smaller values of n. And it's just going to be multiplying by that value of n each time. It's the same thing as doing it iteratively with a for loop. So hopefully you can understand the difference conceptually between an iterative approach where we're talking about a loop, and a recursive approach where we're talking about multiple function calls, and we're calling the same function over and over and over again until we reduce the problem to one that we actually know how to solve. And so this is called the base case. Is if you get down n equals 1, that's like the end all, that's where the problem ends. But essentially, if these methods returned a different result for some value of v, you would say same equals false. And then we just want to get that value of same. And so hopefully it's going to be true. And so what you would do, we can go ahead and let's just test the recursive first. So we can test the recursive. Let's do it with 5. And again, we get 120. That's the exact same thing as we got when we did it iteratively. It's 2 different ways of doing the exact same thing and getting the exact same result. So now if you call this static Boolean method, remember we wrote a static Boolean method that will return true only if these 2 methods return the same factorial value for n equals 1 all the way up to n equals 10. And if any of them are wrong, then the method returns false. But here, this method returns true, which means that the recursive method, this method which calls if else, does the exact same thing all 10 times as the iterative method. So that's sort of the example, and that's how it works. Let's talk about another type of recursive method. We're going to talk about the Fibonacci sequence. So I don't know if you've heard of this before, but the Fibonacci sequence basically works by saying that the first 2 numbers of the Fibonacci sequence are 1 and 1. And then all the next numbers are just going to be the sum of the previous 2 numbers. And so that's an example of a sequence that is very, very easy to implement recursively. And I don't even know how you would implement something like that iteratively. Like, could you figure out the 28th Fibonacci number just with the number 28? Could you do something to that 28 to get the 28th Fibonacci number? Because if you can, it's iterative. But if you have to know all of the other previous Fibonacci numbers, then it's recursive. So what you would do is you would say public static int Fibonacci of int n. You know, you can call it whatever you want, but let's say we want to get the nth Fibonacci number. So let's write some quick documentation here. I'm going to scroll down so y'all can follow along. We're at the bottom of the class all the way down here. But what you would do is you could say something like this method returns the nth number in the Fibonacci sequence. And so if you can think about how the Fibonacci numbers will go in your head, right? But if you start with 1, 1, and then you just keep adding the 2 previous numbers, you would get 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. And you can figure out, if you're quick with mental math, what the ones would be after that. Or you can write a program that'll figure it out for you. So what we're going to do is we're going to say if n is equal to 1 or n is equal to 2. So you could either make these 2 separate cases, right? You could either say if n equals 1, then return 1, else if n equals 2, return 1, or you can just combine them. You can say if n equals 1 or n equals 2, right? Because we would return 1, because the comment here is that the first 2 Fibonacci numbers are defined as 1, and you have to know that. That's called the base case. If you don't have the base case, if you simply just say, oh, the Fibonacci numbers, it's just the sum of the previous 2 numbers. Well, eventually you're going to keep going down. You're going to be getting previous and previous numbers, but where does it stop? And the answer is the base case. So this is what allows you to actually figure out all the other values. If you don't have the base case, you can't get anything. Okay, so now what we're going to do is we're going to say otherwise, if n is not equal to 1 if n is not equal to 1 or 2, what you would do is you would return Fibonacci of n minus 1 plus Fibonacci of n minus 2. So it's going to run the Fibonacci number, and it's going to sum up the 2 previous Fibonacci numbers. So if you were talking about Fibonacci of 6, it would do Fibonacci of 4 plus Fibonacci of 5. Well, what's Fibonacci of 5? It's Fibonacci of 3 plus Fibonacci of 4. Well, what's Fibonacci of 3? It's Fibonacci of 1 plus Fibonacci of 2. Well, what's Fibonacci of 1 and 2? Well, we know what those are. Okay, so you're going to build your way up. You need to build up the other Fibonacci numbers starting from this base case and calling the function on itself over and over again with smaller and smaller values of n. And so, you know, for example, Fibonacci of 4 returns, what would that be? 1, 1, 2, 3, right? Because we have, you know, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and then, you know, 144 or something, right? But you would just keep going like that. So then if we, how do we get the 144? Which number would that be? So that would be, is that the 5th number? No, it would be the 8th, the 10th. It's something, it's like the 12th Fibonacci number, I think, right? So we can go ahead and test that out. So then what we're going to do is we're going to go ahead and compile it. And then we need to, let's finish the documentation here. So we have a description, then we're going to say param n, the number Fibonacci that we want. So the, you know, the position in the Fibonacci sequence that we want the number at, or something like that. There's really not a great way to describe what n is, right? But you could say return just the nth Fibonacci number. So sometimes these things get a little redundant. but you know, this would be a very high quality comment. And this is something, this is like this is an example. This is basically the type of wording that you would see if you went to Google and you pulled up API for one of those string methods or scanner methods or math methods that we were studying. Is it would basically be about this long and give you about this level of detail. And remember, just as a review from the previous lesson, if you go to documentation at this point, you can see this really clean documentation. And so you're looking at, this is a class for, this is class as a sandbox for demonstrating Java concepts. I think that's a Javadoc that we wrote in the previous lesson. I gave a name here, a fake name. But you can go ahead and look at this, right? So it has a method summary. So these are the methods that we wrote. And then we went kind of ham on the documentation for the factorial ones and for the Fibonacci. So let's click on Fibonacci and you can see that pulled up right down here. So it says this method returns the nth number in the Fibonacci sequence. For example, Fibonacci of 4 returns 3. So then you go ahead and get that. And then you can go ahead, we can try that, right? So I think we were testing the 12th number and indeed we get that 144 that we were looking for. The last thing I'll say is that you can also have void recursive methods. So what if you wanted to have a method that prints a certain number of stars? So you could say public static void print stars of int n, okay? And then print characters of int n. So what it's going to do is it's going to accept a number of times that you want to print a particular character and then the character that you want to print. And the way that it's going to work is if n is equal to 1, it's just going to print a character, okay? But if n is bigger than 1, it's going to print a character and then run print characters again with the next smaller value of n. So here's what you do. So you say if n is equal to 1, what you would do is you would say system.out.print of t essentially. So you would just print that character, right? You would print whatever the character is, right? And then otherwise what you would do is you would print that character, but then you would just go ahead and run the method again with the next smaller value of n. So, you know, if you're at print characters of 3 with an apostrophe, then you would print the apostrophe and then do print characters of 2 with an apostrophe. Well, what's print characters of 2 with an apostrophe? You print apostrophe and then do print characters of 1 with an apostrophe. What's print characters of 1 with an apostrophe? It's just the apostrophe. So what's the effect? You're going to end up getting 3 apostrophes. And so we can go ahead and test that. We can go ahead and test it. Let's just test it in the main method just for fun. I don't even know if we have a main method. We might have deleted it at this point. But we got about 2 minutes left. I'm going to try to wrap this up pretty quickly, but you could go ahead and verify this. And this is a void method, right? So you don't set the output of print characters equal to anything. Those stars don't form a string. The action of printing the stars is itself the action, right? It already has the print statement. So you don't print the result of this method, you simply run it. And so you would do print characters of 5, and then let's do $signs. Okay, so now if you go ahead and run it, and then you can go ahead and put hello world here if you want, because we said, remember, with static methods, you call it on the class, but you don't have to write that if you're already in the class where the method is defined. But here we need single quotes because we're talking about a character rather than a string. So now if you go ahead and compile this, and then you're going to go ahead and run the main method, and indeed you get the $5 signs, and there's no loop. We did this without a loop. We could have done this with 25, and there's no loop. There's no loop that's running 25 times. It's 25 calls to the method to get $25 signs. So hopefully that's an interesting concept, and hopefully you can understand that the philosophy of recursion is basically when a method calls on itself, but with further and further reduced versions of the same problem in order to be able to reduce the problem to one that you do know how to solve, and then you work your way up and figure out the values you're actually looking for. So I think that's enough for this video, and from UMills03, thanks for watching, and please subscribe.